It's my pleasure to announce the next speaker, who is William Kempton, a PhD student at the Oslo School of Architecture and Design.
That's right.
Welcome.
So, hello. So I belong to the design part of the architecture and design. Just to make that clear. Okay, I'm just going to talk a bit about 3D printing and online tool offerings, specifically for the purpose of product design. I'm just going to take you a bit through who I am, just briefly, and I'll go talk a bit about what I'm actually doing. Give you a short introduction about 3D printing. I don't really need to go the basics here, obviously. This is not the place. But I just want to talk a bit about it from my perspective. Then I'll talk a bit about the services in the cloud that exist, and I'll talk a bit about services specifically for product design and 3D printing. And showing some examples, and maybe we can have a little discussion later. So this is my school. This is the Oslo School of Architecture and Design, and also Hans Gerhard over there. We both work here. I'm a PhD student. I just started off 4 weeks ago. So this is my master thesis, which was called 3D Printing Unlimited. Is the 3D printer our next home appliance? And I really regret that title, the question mark, because what everyone asked me was yes or no. So I should have written, knowing now that I'm a PhD student, the 3D printer as our next home appliance, no question mark, because that would have made it like a research question. Okay, so this is just an overview of what I was doing on that. So I was going through the sort of fundamentals, trying to explain what it was all about, looking into the possibilities, talking a bit about practical, sort of putting the possibilities into sort of practical purposes, and then I focused a lot about sharing projects, because I think that's actually a really important part of 3D printing and collaborative work. So this is just an example of stuff I was experimenting with. So actually playing with failure, which proved to be a very interesting thing to work on in the early days of 3D printing, because there's so much failure. So this was actually just seeing what happens when you force the machine into doing something it can't do. So experimenting with textures and forcing the machine to fail. Right, that was the background. I'm just going to talk a bit more now about what we're actually going to talk about, which is the 3D printing services. So I use the word additive manufacturing because that is the word which for me is more general about. I think 3D printing belongs to additive manufacturing. That is the realm, and 3D printing is probably more specific. And it's definitely gaining a lot of traction in the field of product design, and it has been for a long time as prototyping, and now maybe more as a manufacturing technique. So I've been searching a bit through the services that exist, and there are actually quite a lot of online services that exist on the net. And I'm not going to present these in a sort of a detailed way, specifically sort of looking at each program, but looking at the area. And also, I want to emphasize that this is really a field of continuously expanding offerings. Okay, 3D printing, it's you got to start off with CAD, and then you got to make a G code, and then you got to have a 3D printed object. I need to have this to explain to people who don't know what it is. And the interesting thing is really, for me, is more in this area, because I rely on guys to actually make good 3D printers. So that's not my field, it's more what happens before. And what is interesting is that this is all based on, CAD is very much based on traditional manufacturing methods. And then we have this really incredible device that can allow us to make free-form objects. So it's kind of a twist. There's friction. So these are some of the advantages of 3D printing. It's basically, if you want to use the sort of the good sides of 3D printing, it has to be something that is either enhanced, so couldn't be made in any other way. This table, for example, you could probably do it in wood, but it wouldn't be feasible. So that's a word to take into account, feasibility. Computational design, things that are generated from the computers, where certain inputs decide what happens. And then there is custom design, and for those of you who didn't know, that product is actually the most, is the default manufacturing technology for hearing aids is actually 3D printing. And they make millions every year. Yeah, lots of nice techniques. So, CAD. This is SolidWorks and CATIA, and this is actually what I used to experiment with failure, and it just felt really wrong. Just doesn't, I don't know, there's something working with these programs that with a 3D printer you just end up with a lot of geometric shapes, and it's not I don't feel right working with it. And I'm going to show you the next slide is the overview of all the services that I found, but just talking a bit about services in the cloud, they are really powerful. I mean, I don't know if you've ever used programs like Google Drive. They allow you to do something and then it's all on the net. You can so easily share what you've made because it's already out there, and you can just send people the link and allow collaboration. I do this with Word documents and Excel files. Why can't we do this with CAD files and making things? And there are some that offer this. This is an overview of some of the services that exist. So I'm just going to go through actually what they all are. Shapeways is a provider, like a 3D print provider of any kind of, you can upload any kind of model and you can buy a golden ring, a silver ring, or whatever. Then you got Tinkercad, which is a very sort of it's a CAD program actually based on people who don't know CAD. So you can open up this browser interface and you can add a box and you can decide the shape. It's a bit like SketchUp, very simple. Autodesk Shapeshifter is a sort of experimental generative tool where you can go in and you can start off with a tube and you can make it, you can warp it and add some textures to it and really work with sort of generative tools without actually doing a lot of thinking. You can just sit there and play. And then there you have things like GrabCAD, which started off as more like a sharing platform, but they've gradually become more like a tool for collaborative sharing, where they have like a professional service where you can do like CAD collaboration. I think interesting programs for me that are coming up now are things like 3D Hubs, which is a distributed provider of 3D printing services, unlike Shapeways, where they make it everything in Shapeways. With 3D Hubs, you can, if you have a 3D printer, you can say that I have a 3D printer, and my 3D printer costs $1 a minute to use, and if you want, you can use my 3D printer. Really interesting. Don't know if you've heard about nervous systems. They also work a lot with generative, I would say maybe generative art or sort of experimental products. And they have applications that allow you to go in and customize your objects in very interesting ways. So in order to sort of get an overview of this, I had to put it all in a scheme and try to sort of figure out what are these programs. And it's very difficult to try to sort them out, but I sort of came to some common parameters that are important for looking at it in a product design perspective, which is how well can you construct things in the program? How do they allow you to collaborate? How do they allow you to visualize? So that would be on different platforms, or actually the sort of viewing of the object on the website. And also, how do they integrate with additive manufacturing? So this is putting it in a scheme, a sort of cross diagram. So you have quite a lot of products that services that focus on construction. It is a bit misleading showing it like this because they are so very different, but there are varying degrees of abilities to construct. And on the far left, you have things like Fusion 360, which isn't really a pure sort of cloud application, but they say it is because it's web-based in the application. And then on the far right, you have visualizing, pure visualizing, also collaborative services such as Sketchfab that allow you to upload a model and you can texture it online. It's almost like a render online. And then collaboration is how they allow you to collaborate. And then on the far bottom there, we have integration with additive manufacturing services. So this is an interesting example because this is the Amazon 3D printing store, which came out very recently, about half a year ago, or even less maybe. And it's actually this is a product template where you can decide how much or what kind of features your product should have. So it's a product. It's not a product per se, but it's like a product domain, and you can customize it for your purpose. It is a doll. It's not a telephone or a car or anything. But let's try to be sort of let's try to abstract it a bit. And what we're seeing here is actually a product which you can say what kind of features it should have, and you can order it. And Amazon is neither the designer nor are they the producer. So and the designer isn't necessarily the producer either, because this is made by someone called Mixi Labs, and they have the service on Amazon website, and it's made by another company which is called Sculptio. So it's actually there's a lot of distribution going on, and no one is taking on everything, unlike the sort of artisan designer of the past. And it allows you to put in text, facial features. Okay, this is made on a Z-Corp 3D printer, and it's basically varying its color, texture, and size. No real like multi-material features or anything, but this will come, I'm sure. And it's all made by a third party. This is another service called Tweakit.com, where this designer called Annie Zellian has made jewelry, and it's totally customizable. You just write in, you have two variables. You write in a word or a name, and you decide what kind of material you want. And Tweakit here is the facilitator of the service. And even though it may seem, it's a pretty simple product, but the designer behind this, she really needs some inside knowledge to be able to do this. She's probably thought of the fact that the font is a continuous font, obviously, that it fits all together, that it's not produced in separate items and it's all going to come out of the printer like rubbish. And this is another feature. This is another service called. This is actually Umagine, which is the sort of the Ultimaker version of Thingiverse. And it's a bit different. So Umagine is a service where you can upload STL files and share them. But they have inside the website, they have sort of, it's a bit hidden, but they have this sort of template, customizable template site where they have this is the enable hand. And what you can do is actually just type in your sizes. So you can write in, this is, for me, 85, and this is 97 millimeters. And then you go on. Well, you need this thing, because it's still the computer and your hair, which is, that link is also really interesting. That's a huge area right there. And we still use this thing, and it's a good tool. And then you come on the next stage, and then there is the possibility to actually change what kind of palm style you want, the finger style, how much padding do you want, and it's all when you write in here, it will automatically update. And then in the end, you write in your email and you get the STL file. I think this is based on OpenSCAD, probably. What it doesn't do is generate a request to order manufacturing of this product, nor does it talk to the 3D printer. But hopefully this will come. So they don't, as one of the attributes that I was showing earlier is how do they interact with additive manufacturing. This doesn't yet have such a good collaboration. You get an STL file, but you still got to take that STL file into a CAM like Cura, slice it, print it, which is a lot of steps. I don't know if I'm supposed to show this because I'm yeah. This is a online CAD program called Onshape. Please don't sue me, Onshape, because it says in the disclaimer that I'm not supposed to show this, but this is a really cool new CAD application, which is actually online, and it's amazing. It's 70 people are working on this from the SolidWorks people have sort of gone over to make a pure online parametric CAD program. And this, now it's getting really interesting. And this is, I should have had the sort of Firefox browser window around it, because this is all web-based. And that's really, really interesting. I still just make vases. That's sort of I have no time to experiment all these programs. So I just make a stupid line and I revolve it. But that's really interesting. So this is a sort of a generic design methodology, which comes from some professors at Aho. So this is how a generic design process works. You start off with seeking information, you analyze the information, sort of, okay, what have we found in the shop? We want to make some sunglasses. There are a lot of green sunglasses. And then you sort of synthesize that information. Okay, so you go, oh, the trend is green sunglasses. Let's make green sunglasses. And you conceptualize it, and then you engineer it, and then you spend a lot of money on tooling and all that. Then you manufacture it, and then it's on the market. And I think this is where it's intended, this is where the sort of rapid prototyping comes in. Sort of not actually additive manufacturing, but prototyping. This is the way it works in a design process. Now, if we start thinking of how it could be if we start using the additive manufacturing technology to make things, it would look totally different, because you don't need to do tooling and you don't need to do all these heavy investments. It's distributed, so you can You can do that. You got to do the same sort of design process of gathering information and analyzing that information. But when you start synthesizing it, it's more of a loop where you go from validating, does it work, till, oh, this is cool. We'll put this online, maybe as a beta, and people buy it. And the prototyping method is the same as the manufacturing method because you're 3D printing it and you're selling 3D printed objects. Could be another 3D printer, like an SLS machine or something. And then you can sort of iterate your product around and around. And in fact, that's really interesting because a product doesn't need to be complete, ever. This is just a very simple example of that. This is something I made. It's a sort of ergonomic handrest for a 3D connection mouse. I don't know if you guys have that, but it's really annoying because it lifts from the table. So I just made that, and I didn't really think about it, and I put it on Thingiverse. I'm sure you've experienced this as well, where you've done something, you share it, and then people start downloading it, and they come out with different versions of this guy, Ben Tommy. He made it for a bigger version of the 3D connection mouse. And then it was made by another guy, and he took a picture of it. But I had to actually share the SolidWorks file. And I think he's probably an engineer, because not a lot of private people have SolidWorks. So that's restricting it a lot. Imagine if this was all online, if you could do all the development process online and really sort of use the power of sharing. Just to bring into this sort of bit sort of eclectic presentation, I just want to present sort of a little model that would be really cool. It's exemplifying a bit the processes that I've shown earlier, but imagine if the user with his needs could go somewhere on the net maybe, and instead of buying a finished product, he goes in onto a template and he can make that product his way. There are huge opportunities. That's 20 minutes. There are huge opportunities in that area. How do you transfer information from the user onto, how does he know what he wants? And then you have the designer with his know-how, because I still think you need someone with, I mean, okay, more people are going into 3D printing and it's getting interesting and people are learning it, kids are learning it. But you still need a designer, in my opinion. Someone who has deep understanding, inside knowledge, or sort of has a saturated knowledge. To make this product with all the right parameters, who knows what's the right thing for glasses, for example? What are the right parameters? What should be on the template that the user can do to change in order to have cool glasses? And then, whenever this is done, it's then sent on to the manufacturing, and they have their know-how on how to optimize the printer, for example, and use the right printer. And then he gets that product. This is a model, could be a model for a more customized way of, or a better way of allowing customizability in products. And it's all about scalability. That's really the difference between artisans of the past and artisans of today, is that they can tap into third-party services. Lastly, I just want to bring this up, which is interesting, which is in a design education, the user-centered design process, you're actually adapting a specific product to a specific ergonomics almost, and specific needs, and making them better. And how do you apply that to mass customized objects? I don't really know, because once you start introducing all these new variables, things get really complicated. Right, that's it. Thank you.
Thank you.
Questions?
So we have time for one question or two.
So probably an interesting note would be that usually there is a manufacturer, there's a designer, and the user, and they're usually separate people. But once you have a 3D printer, you can be the same. That same person can be all three. And so I would say if there's information loss with those three overlapping, with the diagram with the three overlapping circles, then if they get closer to each other because there's less information loss, I think the process will go more smoothly because there's fewer, there's still iteration between producing something and redesigning it and then using it again, and then, but there's a little less information loss. So maybe you have a remark on that as well.
Yeah, but this is, I mean, this sort of Venn diagram is very difficult to use, obviously, because it's, I think it's probably the most misused graph, probably. But I absolutely agree. It could, I mean, this can be scaled within the circles, and there could be more circles, like this aggregator, for example, the person who is not the designer, or not the producer, or not the user, which is simply providing this, for example, and all the other actors in between. But yeah, it's interesting how this can really scale. Any more questions?
Quick question. So, I mean, you touched briefly on it already, but I'm just curious, where do you think the biggest bottlenecks in this process are in terms of bringing more people on board?
A bottleneck for what?
For the process of creating, essentially, you know. And you had a nice slide in the beginning going from CAD to the physical model. In your mind, what are the biggest bottlenecks there?
I think, I mean, there are a lot of bottlenecks. There is always the sort of the hope that there will be more complex materials and things like this. There are also bottlenecks in how we learn to design, I think. The things that I learned as an industrial designer aren't really relevant. They are, but a lot is not relevant for this way of making things. And we're taught it in a very different way, that it should be huge, like big steps going on, and then you end up with something. And that's not the way it works. So maybe the bottleneck is that designers should start doing software engineering and vice versa. But there are a lot of bottlenecks in different areas.
All right. Thanks
Yes.
again.